Okay, so come to the NAT. Let's do the, okay. So go to add and create a destination NAT policy. Okay, fine. Original packet. Okay, so guys, here is actually something is there. Okay, I will explain later on because you guys are confused, have some confused. I'm not going to talk about the zones first. There is some kind of confusion. Okay, I will explain it later. So outside interface, my destination interface is outside. No, I'll talk it later. So here what we can do, we can give a source IP and destination IP we can give. Okay, but we can also mention that traffic is 443. Okay, here whenever traffic would come for the HTTPS, okay, source would be whatever your source. Like here my source is 1.1.1, 1.1.1. Okay, first try to understand this. And your destination is 2.2.2, 2.2.2. This is clear, guys, till now. Source is 1.1.1, destination is 2.2.2. He will initiate traffic only allowed on HTTPS. So what would happen? Here we are not going to do a source NAT. Here we are going to use a destination NAT. So we will choose a static IP, and here the translated address. Okay, so here I have defined that 172.16.1 dot suppose 1. Okay, so what I have did that, just take the example of this. Okay, so whenever he will insert a traffic, source is 1.1.1, destination is 2.2.2, and the port number is 8080. Okay, this is request should come, it will move to this. So here in the original packet, let me change it. Instead of HTTPS, I will make it on 8080. Okay, okay, so see that 8080. So whenever the source is 1.1.1, just source is 1.1.2 and the destination is 2.2.2, whenever they will initiate a packet for 8080, at that point of time, my static, the destination IP would be static IP, and it will change to 172.16.1.1 with the port number 443. That's how we can achieve it, right? Now you got my point. Okay, any doubt? Nothing, right? Whatever I have written in here, now come here. Okay, so what I want to show, just take a look here, and then need to understand. It's very simple, no worry. If you ask me, I will explain multiple times whenever. So just see that. Don't think about this PC first. Okay, like your IP is 172.16.1.1.1. Okay, and he's accessing port number 443. Public IP is 2.2.2.2. That's it, nothing else. But the condition is what? Whenever my source is what? 1.1.1. Fine. Destination is, this is my public IP. Whenever this user will initiate a traffic, it should initiate a traffic on 2.2.2 public IP only, right? Port number, he will initiate a traffic 8080. That's how we have made the configuration in original packet, right? This is for the original packet. That's how. So if source is 1.1.1, destination is 2.2.2, when he initiates the packet on 8080, see that source added is 1.1.1, fine, no doubt. Destination is my public IP 2.2.2, and the services we have defined 8080. That is fine, guys. So whenever if this kind of traffic would come to the firewall, whenever the source is this, destination is this, and port number using 8080, at that point of time, what you will do, firewall will, I'm telling my firewall, whenever if this traffic is coming 1.1.1 to the destination 2.2.2 with the port number 8080, what you will do? You will change the IP, NAT the IP is 172.16.1.1.1 with the translated port 443. Okay, with the translated port 443. This is called also port forwarding and NATing. So what is my translated packet, guys? Translated packet is what? Translated packet is source IP is the same 1.1.1.1. Destination IP, what I have written, 172.16.1.1, and port number is what? 443. Simple. It will just NAT it, right? Nothing rocket science. Got my point here, guys? Okay. Now come. Can anyone let me know what would be the source zone, guys? Let me explain. Firewall, outside. Okay, and this is internet, and this is PC. PC IP is 1.1.1.1, and this is DMZ. Actually, we don't have a DMZ, guys, so just let me remove and just type inside. Sorry for that, because we have not created an DMZ now for the lab, so just type inside only. Okay, and that's it on PC. Group IP, we know that 172.16.1.1. This IP is 172.16.1.2, and public IP is what? Public IP is 2.2.2.2. Okay. So guys, just need to concentrate here the zone. Okay. Source is this. So source is what, guys? What is my source here? This PC want to connect this one. Okay. So in this condition, what is my source IP? Source IP is 1.1.1. So what is source zone, guys? Okay, let's put it outside. What is my destination, guys? IP. What is my destination zone? That is outside. So see that here for the always remember for the destination NAT, your source and your destination zone both are outside. Understood, guys? Your source and destination all the time is outside for the destination NAT. Why? Destination NAT, guys, don't be confused and don't forget. Okay, destination NAT, your source zone and destination zone both are the outside. Very people will many of the people will get confused. I'll let you know why. Your source IP is public IP 1.1.1, and that is belongs to the outside zone. That is fine. Even my free public IP 2.2.2, that is also public IP, and we know that in the firewall, this public IP belongs to the not here actually, but belongs to the outside. This is a public IP because definitely in the inside it has a range of something 172.16.1.0, whatever it is. Okay, so this is my inside zone, suppose, and inside zone has some kind of subnet. Okay, if there is would be any other interface, they have some kind of other subnet 10.00 subnet. So this public IP all the time belongs to the outside only. So that's why here source is also is public, it belongs to the outside. Your destination is also is a public, it belongs to the outside. So for the destination zone, your source zone and destination zone both the outside. Guys, very good. Understood? So here in this condition, my source zone is outside, destination is outside. Interface just give outside interface. Okay. Outside interface. Okay. Port number we are using 8080. So, okay. Source IP is 1.1.1, destination is 2.2. Whenever source IP is 1.1.1, destination is 2.2. If the try to access on port 8080, if this traffic would come on the 8080, static IP change to 172.16.1.1 and forward the traffic on 443. It is very simple. Now, okay. And now we suppose is this PC. Okay, this outside network want to access my this network. Okay, this PC. What would happen on the port 443? I want, as you guys said, both are using 443. Okay, even for the if it is 80 and one is 443, we know it's very simple. Okay, let's do the lab for that also. We create one more policy. Keyword DNAT, any name DNAT policy. Come to the original packet. Source zone is outside. Destination zone, we know it's outside. Destination interface, connected outside interface. Yeah, here is the catch. So if it is accessing on HTTPS, that's it. I don't want. If it is accessing on HTTPS, okay, here is condition, as I explained. For the second, this is the first one, which is accessing port number 80. Okay. Now I'm again making this diagram. Outside. This is outside PC 1.1.1.1. There is a 2 PC 172.16.1.2. There is another PC 172.16.1.1. So both are using 443. Okay. So with the help of port forwarding, this one is achieved. Okay. Now if this one try to access this PC, so what would be my source IP? Source IP is 1.1.1.1. Okay. Destination IP is 2.2.2.2. Okay. And port number, I would say 443. 443. This is my original packet, guys. Okay. What is my translated packet? Translated packet, the source IP is the same 1.1.1.1. Destination IP, it has to be forward to this. Okay, I will show you. I'm just you will see that how it is happening. Okay, port number 443. What we will do here? There it was we have selected the 8080. Here we will select only HTTPS. Okay, HTTPS. Source address give the same IP, guys. 1.1.1.1. Okay, fine. Destination IP give the same 2.2.2.2. Fine. This is your original packet, and we are good. Okay, we are fine. Traffic is coming on port HTTPS. Come to the translated packet, to the static IP. Okay, sorry, 1.1 done, na? Okay, I'm sorry, guys. Okay. And I don't want to translate the port here because I want to access, because this PC also supporting 443, and the original packet also coming on 443 HTTPS. No need, right? It is not forwarding, nothing, not right. Type okay. It's done. See that? You just understand the difference between these two. For last two, see that. Come here. Here, what is happening, guys? Just focus on. Let me increase the font if possible. See that. See that. The source address is what? For last two policy. What is my source address? 1.1.1. This is for the first one. Okay. Destination is 2.2.2. Okay. And service is 8080. Whenever this traffic would come, it will translate to destination 1.16.1.1 on the port 443. And if the same traffic would come, source is 1.1.1, destination is 2.2.2. And if traffic is coming on HTTPS, then it is translated to 172.16.1.2. It's very simple, guys. We can achieve if there is a two server accessing on same services. So that's how we can achieve it. Generally in the network, it should be some different port services. Okay, but anyway, we can achieve it. So that's how we can see how we can do the destination NAT, and how we can also, with the help of port forwarding, we can with the help of one public IP, we can do the NATing for the multiple server as well. U-turn NATing. U-turn is NATing is what? Like you have a firewall, and like we have a one DMG server. Okay, DMG server, guys. Suppose, and we have a inside. Okay, we have a inside one PC. Okay, like this PC has an IP of suppose 10.0.0.1, and this PC has a public IP. This one has a inside even in the DMZ it has a public IP 2.2.2. Public IP is, this PC doesn't have any local IP. This PC has a public IP. Okay, so this kind of scenarios, this PC, if you want to access your local DMG, is he able to access, guys? This one is a private IP, and your DMG server, there is a one server at DMG which has a public IP assigned. So if this PC one try to access this PC2, is it able to access? No. Why? Because this is a private IP, this has a public IP. So at this time, once we do the NAT, that is called U-turn NAT. This is called the U-turn NAT, nothing else. Because why it is different? Why? Because it is happening inside the local side of a firewall. Okay, guys, it is not traffic not coming from the outside. But outside we know that it's a public. But if in some kind of scenarios, if you have a public IP assigned to your DMZ, I've already explained, I think, in the very beginning of the NATing. So that kind of scenario. So how we can achieve it? With the same NATing, right? So definitely we are going to use some kind of source NATing. So with the help of static NAT, or with the help of even dynamic NAT, we can achieve it. Any of the NAT. If you use any of the NAT, we can achieve it. So like if we have it depends. Like if one PC only want to access this, if only one PC want to access this, at that point of time, what we can do, we can either use 1.1, only one specific IP. Okay, we can do that. Like a static NAT we can do. Even if we have a full 10 subnet, okay, try to access this DMG. At this point of view, at this point of time, which NAT we can use, guys? So with the help of dynamic NAT, we can achieve it. Even with the help of static NAT, I have explained, we can achieve it. So we can use it. So that's what the all UNAT. Okay. So guys, now I want to ask one question. Okay. This is my firewall. This is outside internet, and there is a DMG, and there's a two server. Okay, two server, and there is you have a 10.0.0.0/8 subnet. This is your inside local LAN. This is your LAN subnet. Okay, and you have a 5 CEO user, guys. CEO, we know that, right? The company head. Okay, so there is a 5 CEO user. Those want to access internet. But those, for them, there has to be some special traffic. Okay, they will not use the whatever the local employee are using. Okay, whatever the local user are using. No, there has to be go for some kind of other IP. Okay, so even there is a one public IP. Okay, this is a public IP 1.1.1.1. Okay, so you have this is a one public IP configured at the interface. Okay,